Good. How many of you are from third year, fourth year? No. Fifth year, AMP background. So today's session is going to be on HAI. Does anyone know what HAI is? Any idea? Okay, so how many of you have chosen? One. Only one. CSE, data science, cybersecurity,
Attendance తీసుకుంటావా ఎందుకు రాని
yes. Civil. What are you guys?
ఏఎంఎల్ ఏఎంఎల్
IDA. Yeah. Okay. How many of you are interested in things like Raspberry Pi and Arduino hardware? We did. Okay. What about messing around with models like probably AI models, running AI models on your phone? Most of you use AI models, but the thing is, you use them on cloud. Like they don't run on your computers, right? How many of you are interested in them or interested in learning to run them on your phone on your own devices? Isn't it interesting? You can run an entire engine on your own device, on your own device without internet connection. Cool. So that's what the session is all about. So I'll hand it over to Jeevan to give you a brief introduction about the session.
So hello guys, good morning. I'm Jeevan. So before we start off the session, I'm going to show you a demo. It's actually not like a demo. So
So to give you a brief about what this is, we have a split screen, right? You see, is it visible in the end? Is it visible? No. Are you lights on this? I think it's a company friend. It's okay. It's company friend. It's fine. Everyone, any sort of friend. Middle rows, it's company friend. It's okay.
uh, you can see there are two windows open, right? There are two versions. And what we're going to do is that we're going to run two LLMs. Now, one is a local LLM and one is a cloud LLM. And I want you guys to guess which one is which. I mean, you can just guess which is a local LLM and which is a cloud LLM. Just give it a guess.
So we're running a local one of the screens and we're running this chart. Data to show maybe like so I know it's right. So we'll be giving you the same prompt and you'll be seeing how fast it is. One of it is completely on the device. It won't be using internet or it won't be using it will be tracking something on the device. So you have to guess which is which. Tabs వేరే అనిపిస్తుంది. Okay, now the models are loaded. We'll be giving it the same prompt at the same time. So anyone has a question for us? Same question will be asked on the two models. Any question? Any random question? Okay, what do you ask? You have something?
Okay.
Okay. Guys, are you sure you don't have anything? Well, take 5,000 together. Okay, this right?
ఏదో టైప్ చేస్తున్నాం అక్కడే ఉంది స్క్రీన్ సెకండ్ స్క్రీన్
Okay, does anyone guess which is which? Which one is the left side of 81? Which side? That's one. It's like a local one or a probably local one. Okay, so we got two conditions here. So Subin is saying the left one is local model. Someone is saying it's a cloud one. So any guesses? How many of you think it's a cloud one? Left side of the cloud one. We got 10. So the rest of you, I'm assuming you think the left side one is a local one, right? Okay, so let's ask another question. I wanna. Okay, we got. What is like we always know what is quantum mechanics, but I don't know the answer. Ask it. What is quantum mechanics? Okay, quantum mechanics. Okay, so there's nothing like that, but interesting. Now, does anyone see the document? Which one is the left one? Loud? Left is loud? You got 10. Okay. 1, 2, 4, 5, 6, 7, 8. We still are 90 people. Wow. Okay. Shall we do one more? Come on, this one then. Let's ask him to this is gonna be the week, but let's do it.
I'll drop. Maybe local.
Enter. Let's see now. Okay. Okay. Interesting. Interesting. So, shall we do the repeat now? Repeat. Oh, okay. Okay. So, my opinion, I think, anyone who thought well, this, you know about the college repeat. This is actually, if you try to go from college, that's what I thought about. Okay. Now, you're done. You want that? You guys. Because of this, I know. Yeah. I'm gonna okay, so those are pretty good responses. Let's do the review now. So the right side model was a cloud model. Left one is a local model. Right side, we had 10 people thinking the left side model was cloud model, but it's not. See, now the thing is, I want you to understand how balancing this was, right? This was running entirely on this laptop, but you guys couldn't figure it out. This is how powerful AI can be. Uh, I want Freeman to explain you the parameters and the statistics of the model here. So,
Okay.
Slide ಮಾಡಿ.
Mari.
You చెప్పాలి. So as you can see, the first model was not on the local version.
Video on.
You guys know what transfer is, right?
Chill.
Chill.
Okay. Let me tell you what. Understand that as a important characteristic of design. For now, the explaining what is the background. The right side model is a 70 billion. So as you can see, a 70 billion is a big number. So it cannot obviously run on the machine. So you have to scale it down or to use a small model if you want to run on your device. So these are the two models we use for the demonstration now. And for the statistics of the model, we have
So for the local model, we have a 3 billion parameter model. So first of all, what are parameters? So uh, think of it as a library. You have if you have a bigger library, you get more information from it, right? So if you have a 3 billion parameter model, think of it like there are three books in a library, and you only get a limited amount of information from those three books, right? And coming to the cloud one, it is a 70 billion parameter model. So there are no number of books. Think of it, take a parameter like a book, and there are 70 billion. There are 70 books in the cloud model. So as it has more source of information, it gives more refined answers. And that's it.
so let's take a statistic here. Now we have things like model parameters, weights, RAM, location, and data set, etc. etc. Let's try to decode what they are. The first one is the model name. So these are the different models of the set we use here. Parameters we just explained. Now the weights. 2 GB on this laptop says. So the model that I loaded, which is a local model, was requiring 2 GB on my computer. But the other one, it needed 140 GB, which obviously won't fit in my laptop, so you have to use it in a data center. Right. So now where did it run? The first one ran completely on the CPU. Isn't it interesting? You run an entire model on the CPU. Then you can use the GPU for that. The second one, it used LPU. You know what an LPU is? This is more powerful than some code you can do that. Now the location. The first one is laptop, obviously, and the second one is a block data center. So you might be more data center have huge servers to load bodies, which has huge amounts of RAM, compared to the laptops. So now the important thing I want you to notice here. The important thing I want you to notice here is the data center. 0 bytes were sent out to the local model. So everything ran completely locally. You didn't use internet for it at all. For the second one, it required approximately 686 bytes. So it costed some amount of money. We use an API for that. So if you're using a cloud model, they will be charging you the model, charging you to use the model. But if you want to do that locally, you can do it with the regular computer. So that's one of the advantages you can have to run the local model. If you run a model locally.
So coming to the advantages and disadvantages of cloud AI and edge AI. What is cloud AI? So you basically run a language model or any machine learning model on a server which is connected to your device. Coming to edge AI, the model runs on your device. So uh, if you take edge AI, there is no latency in it. Uh, Coming to the cloud AI, it will be all even cloud AI might also give zero latency. It depends on the bandwidth. And the main trade-off for cloud AI and edge AI are if you are using the model locally on your laptop, all your information it doesn't it only stores in your laptop, and it is not sent to any server. So your information remains secure. Coming to cloud AI, if you upload any file into the chat, it might be sent to a cloud server, which might compromise your security.
Extended.
So, I'll explain two terms to you, cloud and edge, right? What are the other things you need to possibly here? We have four different tiers. If you talk about model, right? You have a cloud model, which is the top tier. You have a fog model, you have a next model, and you have a deep edge model. Now, all these are different use cases, or based on how powerful the models are, and how demanding the models are. Categorize them. The cloud models are obviously the most demanding ones. So they use NVIDIA's H100 clusters. Anyone who has clusters in? Yeah. Do you want to answer? Prediction GPUs, yes. So it's not just using one single GPU, but using multiple GPUs together. So it's so powerful that you don't even need you not a single GPU is not sufficient to power it. You need multiple GPUs together, connected together to run a cloud model. So obviously, if you want to run something locally, you won't be having that much money to spend for invest on model. So what you try to do is you try to quantize a model, which is something that I'll be explaining later on in this which simply needs to save the audio down and use it on your devices. The second one being the fog model, which is on-premise service. A lot of companies, okay, how many of you have visited startup or any company? Even the startup is server room, right? Anyone who is server room, you just have big racks of computers running around. They just have your entire quality servers running around. So if you want to perform things like that or something similar, you could use a fog server, which is an on-premise service. Specifically for if you want to have an analytics center in college, you can use a fog tier model. Now, talking about edge, it's something that's personal. You can use it on your phone, you can use it on your tablet phone, you can use it on your laptops, but it requires comparatively less memory than fog and cloud models. The last one being the deep edge models, which runs completely on microcontrollers, requiring very little to no amount of memory. 300 kilobytes of memory per monitor compared to terabytes of memory required for cloud. So, think of it two examples now. Let's talk about cloud models. God, and the anyone else? I will answer from this side. Give me names of companies, guys. Deep sea, okay. Here. Huh? Sorry? Clear them, okay. Anyone from this side? Any other ones? We have a lot of models. Come on. Lack of, I love lack of. That's a good one. Anyone else? Yeah. Okay, good. That should be enough. Let's keep fog aside because it's something that a lot of people might not know of. For an edge, for an edge model, I give you a real life example. This is the problem that we built. We'll be giving you a demonstration later on. The same is rapid for Excel, and it runs a model. I do. And not to giving the entire demo, but I'm can you see a computer? Yeah, you can see something, right? You see a camera, right? I'll be giving this demonstration later on in the session. The first thing is Raspberry Pi inside, and this is an example of an API model. It's a complete product. This is something that I built last year. So this could be used as an example for the edge model. And deeper is something that I've not worked on yet, but it exists. So moving on. So we have different stages. If we want to talk about any model, but if we talk about edge model, we have a subject of an interval, which is quantization. So now, what is it? What is training of a model? Does anyone want to guess what training of a model means? Okay, guys. Do anyone know what training model is? We have what is it? They use data from different sources, and
Okay, you want to.
రెడీ ఉంది కదా మనిషి ఎప్పుడు గట్టిగా మాట్లాడు వాయిస్
It is basically feeding out of data in your model so that you can understand what it wants to get and what it wants to build. Let's just say you're trying to build a model in the right context for you. You feed the kind of data so that the model can understand what kind of data it wants to build. You want to say anything over thing? You want to say? Okay, well, let's just proceed with the other thing.
Okay, so thing is done. Let's keep quantization aside for just a bit. Now interface is sorry inference. Inference is nothing but running it on your device. So the light thing that happens if the light thing is running currently on your device, it's called inference. The middle step is something that's important if you talk about AGI because this is where you scale down the model. This is what happens when you want to take a very big model and you want to scale it up so that it can run on CPU, not even use CPU. So we'll be giving you a hands-on on how to quantize an existing model so that you can run it on your phones later on in the session. Now that you have understood what HAI is, let's talk about potential examples of what you can build if you have an HAI model. You can create your own personal LLM that can run entirely on your phone, on your laptop. Jarvis, come on, Jarvis is a local machine, right? It didn't have any service. Tony Stark built it in a cave. And he didn't build Jarvis in a cave, but yes, sort of. You can create your own personal elements if you want to, if you know how to create it works. And robots. How many of you are IPL? So you might have been looking at the report spot. So that time uses AI, uses the local model. You have to understand how these things work if you're interested in things like that. Now, AI and remote locations. There, let's talk about natural disasters that could potentially happen in the world. They happen anytime, right? If that happens, the internet might be shut down. So if that happens, you won't have access to the servers. What are you going to do? If you want to use AI, you cannot use it. So that's sort of becomes important. And the fourth one, if a politician accidentally launches a needle and the entire world shuts down, what are you going to do? You cannot do anything. You cannot have access to internet. You don't have anything. So yeah, these could be potential use cases of having a local model.
So why would people choose HAI over cloud AI? So there are more, mainly there are four reasons for this. The first one is privacy. So whatever your data is, it never leaves your device. So the data completely stays on your device and you use it on your device. It is not logged in someone else's server or anything. And coming to the second point, it's cost. Uh, if you take a cloud AI, for example, let us say Claude, Anthropic's Claude. If you want to use it, you have to pay for it, right? You have to pay for the tokens. You have to pay for the API keys and all. So coming to HAI, it's only you need not to pay for it. You host the complete LLM in your laptop, and it also works anywhere. Like even if you don't have internet, even if you don't have internet, it only needs your laptop's power to run. So it works anywhere. It works anywhere. And coming to the fourth reason, even if your network's bandwidth is low, uh, it can even run if your network bandwidth is low. So it doesn't need any internet to run. Coming to the next slide. These are the major five terminologies of HAI, which you will be using in the rest of the session. The first one is tokens. So what a token is basically is when you send something, when you give a prompt to model, it doesn't understand our human language, right? So it breaks down the prompt into smaller chunks of information called tokens. Token is the language which a model can understand. And coming to the next one, it's quantization. As Sanit said, quantization is basically a process of scaling down the model to whatever size you need. And next are formats. There are many formats to host a model. There are some of them are ONNX, TF-Lite, and CoreML, and inference. So inference is the final output of a model. So when you're training a model, first you train a model, you quantize it, and when you are going to run it, you have to convert it into an inference model. So inference is the thing that runs on a device. And coming to latency, as you all know, latency is the uh, thing which latency is the major thing which takes the time to give the response. Sunny will explain what a token is.
Now, how many of you know these terms before? At least one term. Okay. So again, when we need to explain new things. So tokens. How many of you use cloud? We have people who use cloud. So you might be giving some called context window, right? You have a 1 million context window of you paying model. So 1 million is what? 1 million tokens. So you need to understand what tokens are if you want to have an efficient use or an optimal use of model. Now, quantization is something that you need for specifically HAI models. Formats, now you have multiple different formats. Let's take audio for example. You have entity model, you have Day-4. So, okay, if you take images, you have bitmap, APC, you have PNG, so many different formats. It kind of so it kind of becomes important to understand what kind of format you need or what the uh, requirements of the machine are. Right? So inference is explained, and latency is something that the time taken for the model to take a response and to give a response back. There will be slight delay, right? The delay could after be in milliseconds, but there will be a delay. And that delay is called as latency. Now, let's dive deep into what token is. Now, if I say a phrase or quantization is free, how do you read it? It's assume you are not very say you are not how do you read that? You would read quantization and then you try to understand how that is. This is what a model tries to do as well. It does something called tokenization, which is to break down text to all chunks that it can understand and figure out. And the thing is, every tokenizer, every different model that you people just need, dot, OpenAI, all these things have different token units. So it's not constant. So what this token could be is it's not standard. So quantization, these two tokens, they're not standard. It could be in a different way as well. So what I want you to understand is that tokenization is nothing but taking a sentence, human readable sentence, and breaking it down into smaller chunks so that the LLM can understand. As I just said, there are different tokens for different models. Let's say a tokenizer is something that can understand big chunks of words. So it breaks quantization into just four different ones. Quantization is key and result. But there's a different tokenizer that doesn't understand large number of words. So what it does, it breaks down more. Quantization is key. So it's the same sentence, but the tokenizer varies. This is how context windows affect. This is how your pricing is. This is how everything is. The thing is, you cannot compare tokenization to different models because every different model uses different tokens. So, what could be a context window of one different model, but it cannot be similar for another one. Why do tokens matter? You pay per token. If you use a cloud model and you don't take a subscription, every response it gives is calculated in terms of tokens. So you have to pay in terms of tokens. You don't have to pay in terms of how long the response is, like how long it took to give you a response. The only thing that you have to pay is how many tokens did it use. Second thing is the context window. context is nothing, right? If you keep using same model again and again, it keeps a memory of what all you asked, right? So it refers now to what you quoted every time, and the context window reaches of what you been quoting. It forgets what you said, so it's going to start hallucinating. Uh, Now, generation is one. As I said, if you put in prompt to it, it tokenizes, and at the same time, if it gives you a prompt back, it gives you tokens. Also, the language is something that matters. If you give a prompt in English, the tokens vary. And if you give a prompt in a different language, the tokens vary as well.
Yes.
Right. Why is quantization important for HAI? So, for example, assume that you have a Raspberry Pi, which is which has only a RAM of 8 GB, and you have a 7 billion parameter model, which is in the format of FP32, which is float point 32, and which take a 7 billion parameter model in FP32 format. It takes 4 bytes per parameter, which would ask around 28 GB of your RAM. So as you have only 8 GB of your RAM, running a 28 GB model would be not possible. So you can scale it down to indate quantization. You can scale it down to indate by a method called quantization. And what indate does is that it only takes one byte per parameter. And as it takes only 1 byte per parameter, it, uh, it, uh, it uses 7 GB of your RAM. And if you have any other tasks running on your Raspberry Pi, so giving only a 7 GB to just a machine learning model would be a great headache. So you can even scale it down to int 4, which would take around only 3.5 GB of your RAM. And the main reasons of doing is that main reasons of doing this is that the memory is the wall. So you have you have a limited amount of memory, so whatever you do, you have to do in that memory, right? So that's why quantization is important. And as it is a edge device, majorly Raspberries they don't have a inbuilt GPU, so you can't run a larger model, and it only runs on the CPU, so it is not that fast. And
The important trade-off I want to understand is that if you quantize a model, basically scale the model down, the accuracy drops. So there's a trade-off between the accuracy and the size of the model. Let's assume you have a 7 million parameter model, and let's assume you have a 32 you have float 32 format of the model. Float 32 model. So 32 bits is nothing but 4 bytes, right? So every single parameter contains 4 bytes. So if you multiply 4 with 7, it gives you 20 gigabytes. That's something you can need 28 GB of memory to get the model, which is something that your local machines cannot do. So what you try to do is you scale down the model to indent. 8 bytes is nothing but 1 byte. So you get 7 GB. It's simpler to run 7 GB model compared to a 20 GB model, right? So you can scale it down even further to go down to 4 bits. But the thing is, the accuracy drops. So it completely depends upon the user. If you want the accuracy to be as low as possible, you can go down. But if you want, it depends on you. You just have to do that to see which one works, and then stick to the one that finally works.
so to scale down a model, quantization is one of the methods. Actually, there are many others as well. So we have quantization, which is a few bits per weight, as we said earlier. You use only 1 or 2 bits per weight instead of 4 bits. And the other method is pruning, which in this process, what we actually do is that there are many repeated bits in a model, right? So what pruning does is that it tries to collect those bits, and it gives only a single weight to the whole group of the similar bits. That is pruning. And coming to distillation, you train a smaller model on large one's output. So you run a large model, take its outputs, and give it as a data to another model, and train a smaller model. And the other is NAS.
So we have multiple ways to contact the first standard form that you get 32 floor. So there's two types of quantization. You can do dynamic quantization or you can do static quantization. Dynamic is nothing but movement. You quantize the model on during inference. So it quantizes the model during the runtime. The trade-off is since it's going to be quantizing during the runtime, you'll be having more latency. It has to do it in real time. So the quantization power should be happening a bit slow. The other option is to do a static quantization, which means to quantize a model beforehand, to export it to a certain format, and then you take the format and you run it.
చెప్పు చెప్తా చెప్తాను చెప్తాను ఇది ఏది యాక్చువల్లీ చెప్పు ఇది చదవలేసాను చదవలేసాను చెప్పేసి
So I'll explain you what quantization is, what tokens are, what KPI is. Now the final thing is you have to understand how to make this work. You have to take the model and you have to convert it into it. These are general steps that you have to follow, which are you take a model which is Python class, usually Python, some any model, and what you try to do is you try to export it to a smaller format that can potentially run. And then you copy it to any device and try to run it on. I'll give you an example of. Okay, the thing is, formatting is not one thing. Format and runtime are two different things. So you might be knowing that format is not one thing. So why does it happen? That's because the format and runtime are two different things. Let's say, in this example, Apple uses HEIC, yeah. But it's okay. Apple uses HEIC format and Android generally uses JPG. So these things are, I mean, Android is not really compatible with HEIC, so Google won't be using it. What you, so it's important to have a format that's, relevant to the runtime. If you have an ONNX model, you have to use ONNX runtime. If you have a TF5 model, you have to use LHW. If you have a core ML model, you have to use core ML runtime. So if you use a different runtime for a different format, what run? That's important for you to understand.
So for various devices, we use various formats. So coming to a laptop CPU, while formatting a model, while writing a model, we write it in ONNX. And as I said, the format and runtime are two completely different things. So format is the thing in which the model is written, and runtime is the thing in which the model is being run on a device. So coming to a laptop, while formatting it, it is in ONNX format, and while running it is in ONNX runtime. And there are many various formats as well. Um, in iPhone, in iPhone, both the format and runtime are same. The core ML. And coming to Jetson Nano or ESP32, how many of you people know TinyML? TinyML, only one. So TinyML, it's actually an application of deep edge AI. So we can run machine learning models even on ESP32 using TinyML. So that's the one. And,
Tell them you have started this one. Tell them you have started.
You know that we have some swags over here, club stage and stats, right? If you answer what was we'll be giving swag for you. So whenever we pose a question, maybe not, we don't expect you to give a exact answer. Even if you have a very big idea of the concept and you want to share it, we can go on. It's not being wrong. You just have to know, like, okay, this is how things work. So yeah.
There are people who responded at the beginning, right? What is it? What do you want? Speakers or What do you want? Figures. You want to come and see what you have? Come on. Your activists will making well some smart school. I do see out.
Yes, guys, you just listen to what we are telling you over here. Answer a few very basic questions. You can get the swags, you can get the goodies, you can grab the phone. So just make sure that you're paying a little bit of attention.
Okay, you know what tokenization is, right? So, like, did you guys understand what exactly quantization is? Okay. Can you tell me what quantization is?
There's a chance for you to win some the electronic million card.
So he says ki, whatever models we have, we are going to reduce its size and use it on our hardware. So how are we going to reduce its size? But then, have an idea about that? It's okay if you don't get right now. You want to see that? You want to add?
There was someone who wanted other than you got very good.
So as you speaking of content, like how is it done exactly? What do you exactly mean by reducing the size of the model? You know this?
You need to upload in cache to edit.
You take a float and cast it to an end and hopefully the model set at around number. You said we're going to cast a float to end because the link has a very less size compared to float. Do you think it's going to work? Cool.
And then how quantization works actually. So yesterday we discussed about weight, right? Like how weightage is going to affect my importance of tokens. As I told you initially, we want to depending on the number of parameters, we actually saw that we saw we saw that the parameters, like first we discussed about the equation of the line, right? Y is equal to mx plus c. Yeah. How if we change the value of n and keep the value of y as its constant, like how the equation of line is changing. And then we discussed about if we had a billion lines, then how would the equation of line be? We talked about that, right? So what we will try to do is that, say if I have the same billion number of lines, and using thousand lines, but then I don't want to use the equation. Like whatever that. So in order to do that, what to do? The values of n which are less important. Or what I'm trying to do is that I just pick a very less number of weight and then optimize this number which reduce the loss rate by or by because we are reducing what we can do is that we can take a larger amount of data with less number of tokens probably, but then you can still get the same amount of tokens. You previously thought you did you observe any output like both of them are almost similar, right? Those one was local, one was being run using an API. Like one is having an internet connection, it is passing a request for particular question, and the other one is relying on computer hardware. Why is that input not changing? It is because the weights are optimized on, trained in such a way that though the output, though your model changes, it sort of gives you the right answer. Because an algorithm behind training on your particular data and its weights are assigned, right? Whenever you download a model, all of these weights get transferred to your system hardware instead of some, hardware that is posted somewhere else. Because the these weights are present on a system, that is the reason why you are getting the similar output. Though it is you would get a similar output from the load. Coming down to quantization, what we exactly do, we reduce the number of parameters by actually optimizing even more when we are, you know, if you don't want to, you also get local from Ola, where all the weights are predefined. But then the only issue is that you need some better hardware in order to run those models. As compared to, ChatGPT or Claude, where you just have to send a request via the web. I don't you understood about what the difference between posted elements. And also quantization is nothing but you basically reduce the number of weights that you have optimally so that the output generated by this model, which is having less is still similar to one which is being generated by the model is having more number of parameters. You are not using a context so we are reducing the weight of the model. Like how I don't have an idea of how it exactly is done. But let me tell you that quantization is all about me reducing the number of weights so that my model sits on a smaller hardware. It gives me an output of a well-trained model. I guess I'm clear.
Sunny, Sunny.
I just keep it. Yeah.
Okay, sure. Corto convert ko.
Okay. Can somebody now tell me the difference between what local is and what posted elements? Will because because badges or any badges. I mean, depending on the no money.
We are going to summarize until now. Check the few use like getting you still don't want to answer it, you don't want to do it. Okay, we have something there. What is the difference between the
Recognizing it as a panic it actually.
Global LLM uses system of experts. It's very difficult to run billion parameters on the internet. You should have a category. What do you want? You want freedom? You want value? You want to Hey, you don't want to believe a lot of everything is now somebody
Using this a bit. So let me see.
So what is that unwanted failure? Can you specify that?
No, how to put it? It's reverse actually.
How is it?
Okay.
It's not so much directing issue.
Because you know, we can it's not, sometimes it is not
It's basically a bit too far from the thing.
even see data, what without actually me cutting.
Your wallet works better. You can do that.
The actual answer is turning off.
India.
You are pretty sure. Very, you have to have it. What do you want? Right? What do you want? We want to answer. We want to answer the question.
It won't focus actually. We adjusted the focus. It's manual focus.
Okay, that works. Yeah, how to show this guy?
We'll call one by one. Actually, we're thinking of that, but we sure see. We're saying to terminate to stream. To stream.
You can try.
Huh.
Just open the camera app and
Okay, no one's like.
I open the camera app, but actually, what I'm one thing is in this video to all the participants. వాళ్ళు ఏం చూస్తారు వీడియో వాళ్ళు పంపించారు ల్యాప్టాప్ దగ్గర తీసుకుని వాళ్ళ దగ్గర తీసుకొని చూపిస్తారు కదా అందరికీ పార్టిసిపెంట్స్ గ్రూప్ ఉందా LHW participants.
What makes you so long? Okay, that is one good answer. You said.
What's up, dude?
While my friend conversation. That's a we have another answer here. He also said, also give me that other side. What is more?
Participants group.
Did you come up to this? Yes, okay, here. Do you mean it when
What is the very good model? What is the very good model?
Wait, I need to take a picture.
Okay, so very big model.
Video open this. Right over there.
What?
Regarding you and you guys not even focusing properly. I should probably wait. I think I done second. Huh?
Guys, okay. So my friend here told us last very small question. What is a context meter?
So this doesn't have any sort of
I know
articulation.
you talk about context meter. What is a context meter? You must answer. Like you.
Array.
Guys, here the gravity is answering all the questions. The second one comment on the stage. Are you sure you don't know anything else? Okay. That is actually that is a model.
Oh, sticker. Sticker is I leave it. Something is anyway we're gonna get it.
Don't fix it actually. Just ask for a photo. Can you only the point but it is part of the so what is that?
Good.
One gravity.
Just like entire ground.
Actually, stole this thing from us. Mobile shop actually.
Mobile shop.
Okay.
तीन क्वेश्चन
Trying here. Anybody
ये होंगे समझ
want to go ahead?
सोल्ड
Anyone? What is important?
Oh wait, man.
Why is it that you are going to be for business? No, I if you want to go ahead, what is it? We are the money of what
Yeah, it's not coming. It's by the data.
Yes, sir. Then for official very knowledgeable keyboard. Go ahead, go ahead. Inferences, the model performing of the keyboard, like the validation.
Perfect, no?
That's pretty much your and then that continue with the question. Let's see what is get potato.
So as I promised, I'll be showing you some songs now. Just give me a minute.
I like this whole GP function. No picture.
So, Amit, are all of you part of the participant group? Anyone?
Anyone but for stating right?
Which are part of the WhatsApp group?
Can you see?
So, I'm sending you a video.
6-8.
No.
6-8. 168. 168.
All of you got it? Give me a thumbs up if you got it.
8
All of you got it.
16.
All of you have laptops, right? At least one per row.
Communication.
Okay. Try to open the laptop. Bringing this one PDF.
Okay, take time.
You explain this thing.
Yeah, expansion. Yeah, the camera mode, the camera mode, the camera mode.
Camera move.
Yeah. Yeah, it's out. It's out. Yeah. It's off the whole. You can put something inside to maybe move it. Pen or something. Nothing on it. Okay. That works. Arey, it went inside. Fuck. Shit. Fuck. What are we doing now? Shit. I fuck up, bro. No, how did I even talk? You talk. Check it. I will even.
So guys, actually, did you see the video in the WhatsApp group? Anybody? We have sent a video in the WhatsApp group. Actually, it's a demo video for our project, and we kind of missed the project right now, so we can't show the demo.
It should have. You didn't turn the power on or
It's
what?
better we explain it about. So, how many of you know the part of the mathematics?
The extension bed.
Anybody of you are-
Yeah, it is powered on. But then
Yes.
screens. Bro, how much did you move this thing, bro? I
So,
literally put it over here. You're taking the entire raspberry.
as well.
Oh, yeah.
We
The
have
entire
that as well. This is a problem.
See, you put the keyboard in. With the keyboard as
So this is
when you push the keyboard in.
all the
Yeah. So the whole thing. It's working for the first time. Then we plug the keyboard in. Next thing you know, it's yeah. That sucks, bro. Yeah. And we super glued everything. I don't even know how to remove that shit.
Anyone? So now just scan log and go to the video. Then start.
Why do you put it upside down? Huh? Why did you put this upside down? Because it's supposed to go as a dash cam. And, you know, flip it so that. And you can put the Raspberry Pi upside down. So to glue that to the other part. Oh yeah, that's because of the boards. Yeah, we couldn't do that here. Camera port is here, so we have to. When we plug the keyboard in, the Raspberry Pi move. Demo video. Also, we'll say, very sure and stops the mouth. You can't. So, architecture means it's like an
So
Camera moved when.
we'll just give you the demo so that you can see, right? Why is it shit?
you can just see what this is. My mode is so. Tell you a video.
Have video of it?
Get a YouTube video with some music.
Okay, put that.
Or what I won't play the audio actually.
We don't have audio connected. That's fine.
It is connected actually. HDMI TV. It also goes.
Is that one?
You can also plug it in.
Oh, this cable. Okay. No, no, it's fine. Why the fuck do you have it open? Okay, okay.
ఏ కెమెరా
CDR.
RPR cam hello RPI
हाँ, camera वाला हमारा project है वहाँ पे.
అదా ఓకే
Sound of pleasure है
ఇదంతా కొట్టాలి ఇప్పుడు
वही pleasure है
చేయలేదు నాకు ఎక్స్ప్లెయిన్ చేయను ఆర్కిటెక్చర్ ఫస్ట్ అది పెడతాను
ఇది చూపించే ఆర్కిటెక్చర్ చెప్తాడు
మరి ఆయన ఇదిగా
చేయి
చీరట్లో ఏమేమి రాశారు
అపోర్ట్ అపారం మీద
లేవు కమెంట్స్ లేవురా ఎందుకు ఈయన పోయినాయి చూసాను
కష్టం అంటే కూడా
కష్టం ఏం కాదు కష్టం ఏం కాదు.
వీడియో అన్న తీసాను అప్పుడు కనెక్ట్ ఎట్లా చేసి
ఇది ఉత్త క్రాస్ ఉన్న సామాన్ అంతా కనిపిస్తుంది
చూడగానే నెట్
So this is a video that we made in this project, so you can see it. Supposed to be a car's diagram, so we have a GPS server, we do GPS location on the phone. This is how I set it up on the car. We have something that this is something that we bought off Vinted, and this is a case that we 3D printed. This is a display, and there's a Raspberry Pi inside. Okay. The hole that you see here is a camera, and that is the one that is moved. So the 3D print is blocking the camera.
play full screen అయితే play that video play
The whole objective of this project is to detect potholes on the road completely locally, and then to get to a centers, have a website created for this. So all of the potholes that get detected on the road, they get sent to a website, and the local municipalities can load the website and see where the potholes are, so that they can just go and fix it. That's the whole point of this idea. This is a live demo on the road. The video is not clear, but if you see it on your laptop, you can see the model detects the thing.
It actually detected some potholes on the road. So due to the brightness, we can't see some of the detections. That's why we try to improvise and we played a pothole video in the laptop and show this camera to that. Actually, we wanted to do that here as well, but unfortunately, it got messed up.
To mimic the same thing, what I did at home was I did my laptop, flipped it upside down, and I put. You can see the Dello upside down. Flip my laptop upside down just to mimic the thing, and to assume that there's a car moving, and I set the whole thing up. This is how the thing works. It detects the photos wherever it sees on the road, and the GPS connection, the top left that you can see, GPS connection, whatever it is, you know, was the local municipality do our exit photos.
So whenever it detects a pothole, at that instant, it will take a GPS coordinate like the latitude and longitude from the phone's GPS, and it creates a JSON packet and it sends to the website where the pothole can be logged real time on the website. And the local municipality of that area, they can just look into the map and go to the area and they try to fix it. And there is one, actually, we try to use a principle called Haversen principle. So what Haversen principle does is that
architecture
so what this project does is that it first uses the camera to look at the road, and when it detects a pothole, we actually trained a Unit 26 set model using a custom data set for it, and we quantized it to int 8 as we said earlier. We have 4 GB Raspberry Pi, so we had to quantize it. So we quantized it to int 8 and we run it on Pi 5. Whenever it detects a pothole, it logs it according to the CVRD score. CVRD score is given on a scale of 0 to 1. So when the CVRD score is more than 0.5, it detects the pothole as a major pothole and it marks it as red. It takes the CSV latitude and longitude and it sends to the website. So website is the place where it logs all the potholes. I can even show you the website.
Does anyone have any questions on quantum?
I'm not okay. అప్పటిదాకా వేరే మంచిగా కొంచెం డీటెయిల్గా ఏదో మాట్లాడుతుంది ప్రాజెక్ట్ గురించి చెప్తాం హ్యాండ్స్ ఆన్ గురించి చెప్తాం హ్యాండ్స్ గురించి కాదు వైవి నేర్చుకుంటాం ఓ ఎవడే ఉంటాం ఓపెన్ చేసి ఇది ఆడ లోడ్
This is the website we get for this, and
Recognize the shape of the map. It's our coverage because we tested it in the morning today. So the location here, it got on the website. The website is very easy to check it out. So click that URL. Then see about
actually, if you might have opened the repo as well, you can find it there. And as I said earlier, have a self principle. Actually, we made this project with a point to crowdsource it. So what crowdsourcing does is that we are planning to put this device in multiple cars, and when multiple cars go through a same road and it is the same model, it will be a headache to log the same model multiple times, right? So have a certain principle, it plays a major role in this. So whenever a model is detected, any bottle in the any bottle in the in the 20-meter radius near the bottle would be detected as the same bottle, and it will not duplicate it again. This is what Hansel principle does. These are the four main features of our project. We are completely running it offline, right?
So you might be thinking the only thing is AGI, but no, if you want to convince the whole reason of doing this project is AGI is one thing, and if you want to convert this idea into a real project, there are other problems which you face as well. So four of the problems that we face, I mean, not exactly problems, the other things we targeted when we made this project was that the first thing was to see that story. Well, every portal is portal, right? How to determine how people and how important it's right? So the shape of the portal, the model determines how big it is and how important it is to fix it. That's one thing that we did, other than just taking photos. The second one is it's called hours and data. Now you might be the portal stays in the same location, but there are thousands of hours passing by it every day. So if that happens, what will happen? Every car will detect the pothole, and the same thing is going to be repeated again and again. So what we try to do is every pothole that is within 20-meter radius, it won't get passed by another time. So once it gets fixed, it won't be fixed again, and it won't be detected again. And the third feature, it's not a problem, it's a targeted feature. Everything is first and offline. So even if you want to internet, everything is collected offline on your own device, and many of the internet connection will be pushed to the website. Then we use phone as a GPS server because the most powerful GPS server is half of the not exactly free, but something that you already have is your phones, right? So we thought of taking your phones, and since you carry your phones every time in your cars, you can just use the GPS servers or the GPS model that is in your phone and connect it to the app so that wherever you go, the same location is tracked. So the problems now talking about the exact problems that we face were as I told you, there's a trade-off between quantization and accuracy, right? So the one thing that we faced is we tried to quantize the only four first, and the accuracy is low. We did not like how the model performed. So we went back to intake. Uh, then thermal throttling. We have a RPI active cooler inside. Actually, conceptually, but there's a cooler inside because the thing was already easy and the chip might burn out. So we put a cooler as well. Third thing is that since it's going to be performing real, there are other factors that you have to consider for. There won't be perfect lighting, right? So To avoid that, what we did is we changed, we applied some sort of a filter to the camera so that it detect what was in any sort of weather and in any sort of condition. The fourth one is a motion blur. So if you go rapid, the FPS drops, right? So if you keep going fast and fast, there's a very high probability that the device misses a pothole. So to do that, we try to reach as high as 25 FPS constantly, that even if you're going at 60 or 70 kilometers per hour, can detect the pothole very efficiently. Then deduplication, I just told you how it works. You mentioned that, yes, and the model updates is just like how you can update model, how it can be.
Sure. Different features. On from me.
There are even there are many ways to do this project as well. We used only a Wi-Fi with an active cooler, so we got around 15 FPS for that. We can even try to enhance it by using Coral DPUs and ANATs. So what a Coral DPU does is that it's just external just an external CPU kind of thing. You just plug in and can use it to run your models. So that's one method, and we can use a AI which has. We actually tried to do that. We tried to buy one, but it costs around 15, which has around 13 tops. So we didn't do that. And for the most efficient one, we can use It's Node Nano, which gives around 40 to 45 FPS. But you can see the cost. So
Whole purpose of us putting this thing was to give you an understanding of how to take what you already have and to create a product. Now, let's move on to the board. Anyone has any questions on this thing?
what's the intern group?
You know, we can do that. Then then what about the camera? If it helps with support. If the camera gets locked by top access to the right apply filter to the camera, so it can detect even if it's falling in the train images. So
It's just a basic eye camera, so we can't expect more from that.
well,
If anybody has those cameras, you can look at the code base. And please try to start the Git repo, it helps us a lot.
okay, so the question is, if you're going on a muddy road, you're asking if the muddy road follows the grid. That completely depends on the data set you're doing. So you have to train a model. So depending on the data set you get and how well you start the model, will determine the model. So depending on how well you train the model, it's a different set. Even the person so that's depending on the training time. Any other questions? Start with. Any other questions? Any other questions? Move on. Anyone wants to check out the GitHub repo or okay. For your question, you said muddy road, right? Well, we want to show you the data set about what we use.
Label data set. What will label data?
Label suppressor and label.
It's not properly visible on this projector, but you can see there's a portal here, right? Here. So what we did was we took this photo and we labeled that this is a portal. If you consider this thing as a portal, the model will be taken differently. So it sort of depends on how you take it, how differently you take it. It's a complete segment in itself. So yeah, this is something that you can think of. Excuse me, the portal here, right? So this is not a portal exactly. So we did not flag this as a portal. So it doesn't get considered as a portal. All right, now let's move on to the hands-on session. How many of you are excited to do some hands-on? Why is excited to hands-on? So what we'll be trying to do here is take a Yoda model, which you want. We'll take that model, we'll point at it from 32-bit code type to an integer type. Can you scan this so that you can do it? We will be sending the are all of you familiar with using Google Bharat? Google Bharat is nothing but you can get a cloud CPU or a cloud model that you can run on a time. Instead of running it completely on laptop, your laptop is not very powerful and so try to open this QR laptop. We'll maybe sharing in the file as well. So if you have any questions, just call me or comment as you want. Got something. Next thing is five things. Still around this.
What did you do? You want scan this here?
Under scan this under open this
One. Are you able to access the platform? Maybe even sending the link to the collab network in the WhatsApp group so we can put that in the laptops as well.
I send the link directly on your WhatsApp group as well. So you have your laptops or WhatsApp are open, you can try to open. interfaces. There's no difference, but it's easier to see.
Waiting for your social.
I already reached partying on Delete for everyone ఇప్పుడు అసలు యూజ్ చేసింది కార్టూన్ పెట్టిన ఏం చేయాలి ఏం చెప్పండి మూడు సార్లు అందుకని తీసేసాను ఇది తెలుసు
Any questions on how to use Google Colab? Will everyone open it?
These are the various GPUs you can access for Google Labs. So this is what Google Labs is. If you want to train bigger model, you can train on locally on the laptop, but it depends totally on the performance of your GPU. So even for our project, we try to train laptops actually showed a week long to train. So we took a Google Colab and actually we took a subscription of it and we used the A100 GPU. How many of you people know A100 GPU? Everybody has A100. A100. No one?
లాస్ట్ వేగస్ వచ్చింది ఇంచి చెప్పు ఓపెన్ చేయి అందరికి ఓపెన్ అయినా చూడు అందరికి ఓపెన్
So A100 is the most powerful GPU that we can access, but we need some option for it. So we can use a T4 GPU instead. Can select the type of GPU you want, but you can change the type. And is everyone doing it? Article ready?
ఏడుంది అది వాడలేదు
So, did everyone open it? So, you can read this. Okay, so now the model that we're using is called a YOLO model, which is called you only live once. So, what we're trying to do is we're already taking an existing model. I told you training a model is one of the things, but it takes a lot of time. You need multiple hours to train a model, which is something that we cannot do in this section. So, what I thought of doing was to take an existing model and to quantize it and then to run it on your phone. Hopefully. So the first thing is the setup. So you just have to scroll down and you can see a play button here, right? Can everyone see that? Since you're new to Google Colab, I'm trying to explain how this thing works. These things are called cells basically. You can have a text file or a code file. If you try to, if you click this button, what it does is it runs these commands for you and it stores locally on this for the present session. So just click on this one now and run it. This downloads the model that you want. From Ultralytics 8.4, you're downloading these three runtimes. I just told you, right? ONNX is a type of format and ONNX runtime is a runtime tool that we're using. Let it download, click that button and let it download. If you get stuck anywhere, just call me. I will come there and help you. Once it's done, you can see a green tick here. So if that's done, let's move on to the next one. What it does is basically initializes everything. So this is the work path directory. This is the model that we are using. This is the image size that we're using. These are the initial setups that are required. This is done and done. Now, how many of you remember that I told you there are two types of content? Static and dynamic. You people remember static and dynamic? Okay, so now what we're trying to do is we're trying to do static quantization because dynamic quantization will take time. Take time as in to run. Okay. So just click this thing. What we're doing is dataset is a thing I just mentioned, right? If you want to train a model, you need a custom dataset to do that. So there's a dataset called COCO, which is the standard dataset that YOLO uses. It has 128 predefined classes. So if you are already familiar with a bit of machine learning or computer vision, you'll be understanding what. But if not, it's not really necessary for you to know it right now. Still do it. Once this is done, the whole calibration is done. So all the images that it requires to the pointers and models in a static way, this is done. And now we are exporting the model in an FP32 file, which means a float point 32, which I told you before. This is a standard size that the model comes in.
Hmm?
If it is starting to start to down.
Is everyone done with the setup? The first two cells, these two. Are you so? Viral and Joe. Huh? Please raise your hands if you're done with this. So, okay, good. We'll move on to the calibration part. I hope you're done with that as well. The first one. Is the calibration part done as well or still doing it? How many of you still doing it? Calibration? Okay, I'll give you some time. Done with it? Okay. Uh, Go to the second one and it should be done in 20-25 seconds as well. So, done. Looks like almost all of you are done with it. Now, and only there are different quantification schemes, right? FP32 is a model that you get by default. So once you downloaded the model from the YOLO's website, this is the one that you get. What we are trying to do is we're trying to shrink the model down to int 60 and int 8. So this code block here, what it's going to do is it's going to take your model, it's going to convert it to float into int 8 and int 60.
Right.
So if you
డౌన్లోడ్ చేసిన తర్వాత చాలా మంది సెకండ్స్ రన్ చేయడం మర్చిపోతుంది ఇనిషియలైజ్ చేయట్లేదు అది
ఎవరికి రాదు?
ఇద్దరు ముగ్గురు అదే చెప్పినా వస్తూ చెప్తే చేస్తున్నారు కానీ అందరి దగ్గర పోయి చూడా చెప్తావా
చెప్పు అందరికి చూడు అన్ని నేను ఇడకి చూసుకోవాలి.
ఒకసారి చెప్తావా లేకపోతే అందరి దగ్గర పోయి చూడనా అంటున్నా
చూడు అందరి చూడు అందరికి సెటప్ రావట్లేదు అంటారు. ఫర్ ఎగ్జాంపుల్
Any questions on that now? I'm assuming everyone is in step three. So this is the biggest part of it. This is the code block that converts all the models into its respective quantized versions. So it's done to me. The quantized models are done. Is everyone done with quantizing their models? I mean, it's going to take time, so I'm going to wait for everyone to do it.
Yeah. Sure. So starting it was set up. First one was setup. Setup and you're calibrating with the existing data set. And then we can redo the baseline. Okay. Then it's quantization. I'm here on quantization. Let me know if everyone is up with this. This is the longest time.
It takes time.
It takes 4 to 5 minutes. So if these two rows are complicated.
Yeah.
One.
Sonic.
Instead of the
వీళ్ళకి అయిపోతుందా పిపిటి
PPT is
No.
check if everyone was టోటల్ అనేది చూసాను అందరిది రన్నింగ్ ఎవరు మాట్లాడతారా ఎవరు మాట్లాడుతున్నా ఎవరు మా ఇంటి క్లాస్ పాట
అవన్నీ ఇన్సైడ్ అవన్నీ చదువుకుంటున్నారు ఇంకా చదువుకోవడం How many of you are still without selfie program? Person. Person. I don't know.
కనెక్షన్ పోయిందంట మళ్ళీ ఫస్ట్
అంటే కనెక్ట్ చేసుకుంటాం
మళ్ళీ ఇందాక డిస్కనెక్ట్ అయ్యి పోయిందాం మళ్ళీ ఫస్ట్ వెళ్ళేసాం సెకండ్ దాంట్లో సెవెంత్ చేశాడు అది 8th 9th కూడా రన్ అయిపోతున్నాం వాడు స్టాఫ్ పట్టుకున్నప్పుడు వాడు సౌండ్ అయిపోయి మీకు ఏది ఉంటుంది
You guys see it outside? You don't know. No one? Okay, then you proceed to the next one. So for another question, you can number four same. So what the four saying does is that it's a original model. Usually we have it contributes to problem the format and as you can see here, there is a epidemic and when it's down to intake, it's around 2 So it's basically reducing the size.
On the latency side.
Diameter portion, diameter portion,
Huh? You want to association. Research I think. అదే రకాలకి ఇది సైజ్ సైజ్ నెక్స్ట్ జేటెన్స్ అంటే ఏమి ఎవరో మాట్లాడారు ఓ సిఎస్ అండి accuracy. अच्छा ऑर्डर डिटेक्शन है ऑर्डर ना हाँ कुकिंग वाला मॉडल से उसका डिफॉल्ट डेटा सेट में फोटो डेटा सेट दानी में पॉइंट है and the homework is to give the custom data set and then post it on the that's a so is run the latency system and check these values are you not many so what is the coolest huh what is the ఇట్లా సింప్లిఫై చేయాలి సింప్లిఫై ఇట్లా డిఫరెంట్ వర్జన్ కాంటెంట్స్ ఒక కాంటెంట్ వాడండి ఈ మోడల్స్ మీకు డిఫరెంట్ కాంటెంట్స్ ఇప్పుడు అది ఒక సెల్ దాంట్లో చేసి వాయిస్ దాంట్లో లేటెన్సీ వాట్ ఇస్ లేటెన్సీ లేటెన్సీ టైం టేక్స్ సారీ వన్ లేయర్ వన్ లేయర్ వన్ time data basically. And that basis, since we are using a computer technology, FPS is one of the parameters, and there is the FPS is effective. So it is yeah, and I would say FPS later as
how many of you have completed running four cell? Everyone? Keep doing that. While let's just understand what latency is. Like we discussed yesterday about neural networks have many layers. So what do you do? You move from one layer to other layer. Right? So the file data via filter. So you might your data peaks low. I mean, the movement of data from one to the other, which might slow down your node. Right. There are different ways in which a model might perform to the point which is your mark being marked. It is because the data might be there. And one another important parameter which comes up to getting on layer is that your latency. So let's just understand and give an example. How many of you guys love to play online FPS games? Most of you, right? How many of you have played study? Public? Free Fire. So all of you know that there will be something called FPS, right? which is nothing but frames per second, which totally depends upon your speed. So similarly, inside the neural network, whenever data is being passed from one layer to the other, similarly our data is transmitted over the internet. Depending on the speed, your model might be a good model or your model might be become a bad model. So for whatever model we are using, what acceptable, right? We are going to check the latency of each and every model. Like how fast is the transmitted between layers and even other like actually not for this, what we were trying to do, right? We were trying to reduce this so that the model will be to the point of what we are expecting from the model to do is possible. You can see over there on the output, each and every model, be it SP32, W8, or any model, you can see over the end it is 9.9 FPS, 6.0 FPS. That is the speed of your data transiting from one layer to the other layer. I hope I'm clear. Okay. In case you haven't yet run your more than what do that before we jump into accuracy.
Are they doing it?
Just లైట్ చెప్పాలి లైట్ చేద్దామంతా పోయి
Like, so the higher level, the better. So you don't need a model skill.
Anybody facing any issues? You're currently the sixth sir.
ఏంటంటే ఏం లేదు 11:30 పీపీటీ ఇంటికి వెళ్ళేసరికి పీపీటీ కూడా ఆల్మోస్ట్ రైట్ మొత్తం ఏం చేస్తాం ఇది accuracy. It's just a original DFI market. With by loading DFI. It is a little bit load also. It is the storage fund factor. So so explain that. ఇది అవుతుంది అక్కడ అదే రన్ చేసేసి
As we discussed yesterday, okay, let's understand what we are doing in this fourth block of activity. So, yesterday we discussed about laws, right? So, the laws, different models can be calculated by a different method. Okay. Sometimes it might be using cost functions when it comes from terminals. It might be using optimizers like already yesterday, which is version of negative. Or you can do something like this mean average coefficient. This is quite common in CNN. What exactly happens is that, okay, let me tell you how many of you know what CNNs are? Or sometimes you're interested to know about it. If you want, I'll just brief it out for all of you. Are you interested? Yeah, okay. So, inside a convolutional neural network, what you basically do is that you give it T. Okay. So, what a convolutional neural network does is that it tries to read that particular image and it tries to the important information from that image. Let's take an example and to understand what exactly is happening. Say, if I am like, if I am showing you a picture of a pothole, how like you're moving on the road and suddenly a pothole occurred and you want to have model to fix it. So what my model does is because like is the same on that particular page and it tries to map out what are the important part. Important part of the image will show dark vertical line, dark horizontal line, or light and dark pattern. So what happens is that if the floor is the whole image is not scanned at once. A part of the image is like taken to picture. And it also like one of the important part in the small piece of the image. Like I told you, it must be dark horizontal, dark vertical, and dark and light pattern. In our case, let's consider that we are looking into dark and light pattern because this is the photo. So, wherever the pothole occurs, you might the change of shade from a light shade to a dark shade, right? So, when this image is fed to a model, it translates to a filter to observe dark and light pattern. Yesterday we discussed about shade. So, what happens is that it like the for initially each and every pixel is given one weight. Like how it is yesterday, each and every chapter got its own weight. Right? So each and image, what are the smallest data units pixel, right? So each and every pixel is given some particular weight. And after the weights are assigned to each and every pixel, it is run through a filter. It might be RELU or anything, but let's just consider RELU because you know what RELU is. What does RELU do? It is governed by an activation function where like the activation function files up when it has a negative value and discards that negative value and replaces it with a zero. If it is a positive value, it is passes it forward. So, if all the right patterns are given negative values and if all the dark patterns are given positive values and you run it through a model, what will happen? Your light patterns become zero while your dark patterns become only positive value. So there's no false. Whenever this filter is on, you will observe the dark pattern more clearly as compared to the white pattern. So, like this, when it comes to totally multiple filters, multiple right. After we have running from filter, you basically identify the so in order to train a particular model, you first need to then you compare it with the exact output. So whenever you want to detect a particular content, as we did here, you run through your model and you see what your model is saying. And you give it exact dimensions of the problem. These two are compared with each other and the loss is calculated. How is this loss calculated? It is mean what happens is the average of each and then the mean is applied only the average value. So, instead of applying the mean, you get the loss value. What you have to try to do, like you have to try to reduce that loss. You basically have a better model. So what this accuracy block is trying to do is, right? It is trying to reduce that loss level. As you can see over here, in the first iteration, the MEMC score was 0.63. But then if you see in below over here, if you see it over here, it has reduced to 0.34 and 0.5. Then and then we drop to 0. It got okay. This is basically because there are multiple number of models. If you observe over here, we have an SP32 model, we have a W832 model, which are doing some particular task. So, like this is basically related to one particular model, while this is related to another model. So, you try to calculate the loss at each and every step, and you try to optimize it while reducing the loss.
This is the table for all.
Yeah. So, as you can see over here, this is the table that we can calculate. If you see a image 4, you might observe that it has reduced for 0.4. Initially, we had something like 0.59, right? It got reduced to 0.47, 0.39.
Accuracy and size. Accuracy and size. Trade-off. Size of it.
If you observe carefully, if the size is reducing, you can observe that the accuracy also reduces. The reason is that whenever you trade off parameters or trade off the weights of a model, this directly affects the prediction of the particular output. Okay, I'll give a small example. Say you have one more you only have a single topic to that related to that particular topic. If I propose a function for you, which one would you pick? Of course, the textbook, right? Why? Because it contains a lot of context, a lot of more information compared to a simple topic. Similar analogy can be applied over here. When the amount of data is more, your model has more accurate information, more information that can be used in order to output. But then when the number of parameters reduce, not only is the not only are the weight affected, but also your output gets affected because now we have to work on less amount of information and generate the same output.
Yeah. No. Size of it. Size of it.
Uh, well, everyone was able to do a hands-on. Did anyone get any inputs? If you're able to do it, please raise your hand. Okay, so you might have seen that we have quantized the model LHW and default model that we get. And then we quantize in 16 and in 3. Those are the three different versions that we did there. And as Subin explained you, the every score a drop. So this is the data that I explained to you when I told you about model. There is always data between the size of the model and the accuracy of the model. Now, I want you guys to, be able to do something when you go home. Uh, You can take whatever you learned in this session, and I want you to take the index file that is in your Google Drive, the one that you just pointed, and I want you to run it on your phone totally and take a small video or a photo of it, post it on LinkedIn with the start section. The first people to do it, the first three people to do it, to start from something else, which is different from this one, which are different from these ones. So I hope you all are excited to do that. I'll be looking forward to see this with the present hashtag here. 2042. Right, sir. If you want to take a picture of this slide, you can do it. If you plan on posting it. I'll be giving it like 30 seconds.
Hey, lights bro.
Is it done? I see people saying the word. So I still hope you have the Google Drive thing. There's a slide where guys to fill out. Uh, if you paid attention to the slides in Google Drive, you could have seen what the sizes are, what the FPS are, and what the MMP scores of the three different models are. I want you to fill out the slide, take a picture, and just like notice what happened there, so that you can understand what the different default is. FP32 is a default version. VTX is what you converted it to. So if you want to take a picture of this, okay, so if you want to connect with us, speakers on LinkedIn, and if you want any questions, if you have any questions to reach out, you can do that. All right. Any questions, guys, about the session? Any questions? I hope you learned something new from this. I hope you got to know something new and got to try out something new and probably explore the speed. That is it for the session. Thank you, guys. Thank you guys for your opportunity. So thank you guys for the cooperation. That's it for the session. And you can back to us. Well, I hope everybody should have, probably not, perfect. About an idea. You not you can learn on your system. We can practice on person. Will you try that on a couple of weekends? How do you because yeah, why they explore? But then if you observe incidents and when you might already know that there is a lot of activity.
also the same. Quantization is also about reducing. Something we did cover yesterday. So there are a lot of PDF and you just have to start and you just have to know what I don't have network stuff. Thank you. Everybody can step out of the seat, come down and collect the flags that are open. Any messages or remarks or things that you want, just
Reaction only.
దిగాలి దిగాలి ఒక నిమిషం
Height కూడా ఉంది.